Hello everyone and welcome back. Today we're starting with our first application of differential calculus, which is considering tangent and normal lines. So in our little graph here we can see a curve y equals x squared, which is the parabola here, and we can see the tangent, which is this blue line along the side. So a tangent can be defined as a line which touches a curve at exactly one point, which is what it's doing here, where x is 1, and it has the same gradient as the curve at the point. So the gradient of y equals x squared is going to be the same as the gradient of this line at the point where x equals 1. The green line we can see is the normal, and a normal is a line which is perpendicular to a tangent at a point. So here's our normal line coming down here, and we can see it's making a right angle, 90 degrees there, with the tangent line. So let's go back a little bit and think about let's go back here. Let's have a look about and think about what we know about perpendicular lines. So hopefully you remember from in the past that if two lines were perpendicular and I multiply them together, we get -1. So what that means is that if I know the gradient of one line, in order to determine the gradient of the perpendicular line, I find the reciprocal, I flip it over, and I take the negative of that line. Both the normal and the tangent are straight lines, so in order to determine the equation of a straight line, hopefully you remember we need two things. We need to know the gradient of the line, and we also need a point. Once we have those two things, then we can use the very handy equation y minus y1 equals mx minus x1. So let's do an example to see how this would actually work. So we're wanting to find the equation of the tangent and the normal at the value where x equals 1 for y equals square root of x. So the first thing we need to do is to find our point. So when x equals 1, to find the value of y, we can substitute in and we would get the square root of 1. So that means that our point will be the point 1, 1. In order to find the gradient, we need to rewrite our equation. Square root of x is the same as x to the power of a half. So to find the gradient, we need the derivative function, dy dx, which we find by taking half, multiply by the power, subtract 1 from the power. Half minus 1 is -1/2. We can also write this as 1 over 2. X to the power of -1/2, we can move it to the denominator to make the power positive, and power of a half can also be written as the square root of x. But I want to know the value of the gradient when x equals 1, so if I now sub in when x equals 1, we will get that the gradient is going to be equal to 1 over 2 square root of 1, which is just a half. Let's now use this information to calculate the equation of the tangent. We have our point, we have our gradient, so therefore we can now go straight away and use our equation of a straight line. We substitute in our values, and then we will expand. As we can see here, expanding the brackets. Finally, to simplify, we add 1 to each side, and -1/2 plus 1 is +1/2. So we've got the equation of the tangent. Next up was to find the equation of the normal. We still have the same point. Remember, the normal is perpendicular. So in order to find the gradient, I need to take the gradient of the tangent, I need to flip it over, take the reciprocal, and then change the sign. So that means that the gradient of my normal will be -2. We can now substitute this information into our equation. So y minus 1 equals -2 x minus 1. So simplifying here, We multiply everything by -2 and then we add 1 to both sides and we get the equation of the normal. We can also do this on our calculator, and we are going to have a look at that now. The reason for that is that sometimes we're going to end up with expressions that are not so easy for us to differentiate without a calculator. So what we do is that we type in our expression, square root of x. We don't need to write the y equals. We highlight and choose interactive calculation, because calculation is for calculus, and line. We're wanting the tan line first, and we're wanting the tan line at the value where x equals 1. Now, even though it says point, we only ever actually need to put in the x value that we need. Okay? And this gives us straight away that our tangent line would be y equals x on 2 plus a half, which is the same as what we had here. We can find the normal the same way, so we can highlight and say interactive calculation line normal at the value where x is 1, and we get our normal equation y equals -2x plus 3. So using the calculator can be a very efficient way of finding our tangent and normal lines in TEC-active situations. Let's go back now and have a look at a few past exam questions. So here we have a particular question where we've been given a curve and we are told the tangent to the curve will be parallel. So parallel implies that we want the same gradient. So it will be parallel to the line connecting the positive x-intercept and the y-intercept. So let's find those values. So to find the y-intercept, we know we substitute in when x equals 0, so we'll get y equals -5. The x-intercept we find by subbing in y equals 0, so we would get x squared minus 5 equals 0, x squared equals 5, so x would be positive or negative square root of 5. If we were to sketch this, we will have a parabola looking something like this, passing through the intercept square root of 5, negative square root of 5, and -5. Now, in this case, it tells us that the tangent to the curve will be parallel to the line connecting the positive x-intercept, and y-intercept. So I need a line connecting the positive x-intercept and the y-intercept. Now I will have a little bit of trouble drawing without a ruler, but hopefully we can imagine. That's the line. I want to find a tangent to the curve that will be parallel to that. So somewhere down here, I will have another line which is tangent to the curve and is parallel, same gradient. I can find the gradient of this first line here because we've got 2 points. It passes through the point 0, -5 and the point square root of 5, 0. We use our formula for the gradient between 2 points, which I'm sure you all remember, and we get -5 minus 0 over 0 minus square root of 5, which would be -5 over negative square root of 5. We can simplify by multiplying by square root of 5 and square root of 5 to rationalise the denominator. Our negatives here and here will cancel out, so I'll have 5 square root of 5 over 5, and our 5's will cancel out, giving me just the square root of 5. Now I want to know where the tangent to the curve. So tangent to the curve means we want the derivative. So I need to find the derivative of my original function that we had here. We multiply by the power and subtract 1 from the power. The derivative of -5 is 0, so I don't need to write that. And I want this gradient, so the gradient of this line, to be equal to the gradient of the other line we had before, so it needs to be equal to square root of 5. To get x by itself, I divide by 2 on each side, and so we get square root of 5 over 2. So our answer is D. In this next question, we're wanting to consider the tangent to the graph at the point 2, 4. Let's actually use our calculator for this one, because remember, efficient use of calculators is really important to make good use of your time in exam 2. So if we start with our equation, we're wanting x squared is my equation. So x squared there. I want to find the tangent, so calculation line, tan line, and we're wanting the tangent at the point where x equals 2. Remember, we don't need to put in the y value, just the x value. So this tells us that the tangent line is going to happen at 4x minus 4. So let's have a look then and see what we can do with this. So our tangent line is the line y equals 4x minus 4. We want to see if these points lie on that graph. So we substitute them in. When x equals 1, y will be 4 times 1 is 4 minus 4, 0. Not negative 4, so that one's out. If I look at option B, when x equals 3, y will be 4 times 3 is 12 minus 4. That is 8, so this point is on the line. We can keep going through and checking to make sure, so you could also look at when x equals negative 2 and all of the others to see what we get and eliminate them just to be sure. But we've already got one correct answer, so if you're running short on time, good to select it and move on. Our final multiple choice question for today, we can see here. The normal to the graph of y equals square root of b minus x squared has a gradient of 3. The normal to the graph. We need to first of all find an expression for the derivative. Now, unfortunately, we haven't yet learnt how to differentiate when we've got a function inside a function, x squared inside of square root of x, but fortunately we have our calculator available to assist. So let's get our calculator up again and type in that equation. So I'm wanting to have b minus x squared, minus x squared is my function. We can differentiate this, interactive calculation diff, and we get our derivative there. So we've got our derivative we can write here, which was negative x, look back at the calculator, over square root of negative x squared plus b. The normal to the graph has a gradient of 3 when x equals 1. So if I sub in when x equals 1, I would get negative 1 over square root of negative 1 plus b. The normal to the graph. So to find the normal, we have to take the reciprocal of this and change the sign. So the normal gradient is going to be occurring at, we flip it over, and we change the sign, so instead of negative it'll be positive. We want to know when does this equal 3. Now we could either solve this by hand or on the calculator. This one's pretty easy to solve by hand because this is what we've got. We can square both sides and then we can add 1 to get our value of 10. You could also have solved that on CAS if you would like. So let's just go back and have a quick look at how we would do that if we were using our CAS. Let's keep our annotations there. So what I would do is that first of all I would substitute in here, given we know this needs to happen where x equals 1. Okay, it simplifies for us. I want to know where does the normal of this equal 3. The other way of saying this, I before flipped this fraction. Alternatively, we could flip the 3. So I could say I need this to be equal to -1/3. This will do exactly the same as the way that we did it. And we're wanting to solve, in this case, instead of solving for x, we're actually solving for b, and we get the same answer there of b equals 10. Now, our final example for today, we're wanting to look at the 2018 exam 1. Now, this is tech free. There are actually a couple of different ways you could go about solving this, but right now we're going to focus on what we've just been talking about and the normal. One of the reasons why the normal is very important is that it helps to give us the shortest distance. And shortest distance is what we're talking about for this question. So we want P to be a point on the straight line y equals 2x minus 4 such that the length of OP, of the line segment from O to P, is a minimum. So if I want the line segment to be a minimum, that means we're wanting to find the shortest distance. Let's sketch this so we can see what it looks like. This graph is going to have a y-intercept of -4, and the x-intercept is going to occur where y equals 0, where 2x minus 4 equals 0, 2x equals 4, where x equals 2. So if I was sketching this here, it's going to be between -4 and 2. So we will have a line here. This is my equation of the line, y equals 2x minus 4. And I want to find the point P to get the shortest distance. Now the shortest distance is going to be coming out here and meeting at a right angle from O to P. So this is very important. When we're looking at shortest distance, one great way to think about that is by using the equation of the normal. Yes, so let's actually go about doing that. First of all, the gradient of this line along here is going to be 2. So the gradient of our line given was 2. So the gradient of our normal, we need to flip it and take the negative. Flip it and take the negative. So to find the equation of this line, what I'm having is that it has a gradient of -1/2, and it's the line between O to P. O is the origin. So it's going to pass through the point 0, 0. So I'm going to have y minus 0 equals -1/2, x minus 0, so we will get the line y equals -1/2 x. Now if I know that the equation of this purple line here, the normal, is y equals -1/2 x, and I know that the equation of the initial line we've given is y equals 2x minus 4, I want to find the coordinates of P. This is the point of intersection between those two graphs. So to find the point of intersection between our two lines here and here, we need to solve them simultaneously. In this case, the easiest method is probably substitution. So I will sub one into the other, or I say for them to intersect, their y values need to be the same. So we will get 2x minus 4 equals -1/2 x. I can add -1/2 x to this side. 2 plus 1/2 is the same as 5/2x, and let's add 4 to this side. To get x by itself, we multiply by 2, which will give me 8, and we divide to give me 5. We're almost there, but I want the coordinates of P. This is just the x value. So if I substitute this in to either equation, what I would end up with, therefore, if I sub it into the second equation, I'll get -1/2 times 8/5. We can simplify here and we get the y values of -4/5. Still not good enough. I want coordinates, so I need to write my final answer as coordinates. So the normal, very, very useful for us when we're wanting to find shortest distance. So this particular question, I didn't actually need to use calculus at all, but I still needed to find the normal to answer the question. Part B now, we want to find the distance OP and to express our answer in a particular form. The distance formula is one that is not on your formula sheet, but it is one that you should know. This is distance between 2 points is something that has been taught in maths since about year 9 in most cases. So this is our equation. It's essentially Pythagoras' theorem, isn't it? So x2 minus x1, so our points are the points 0, 0, that's the point O, and point P we had 8 over 5, negative 4 over 5. So we're going to get 0 minus 8 over 5 squared plus 0 minus 4 over 5 squared. We can square both of these. 8 squared is 64 over 5 squared is 25 plus 4 squared is 16 over 5 squared is 25. When we're adding fractions together, we keep our common denominator and we add the numerators. Now this is still not in the form required, so we're trying to simplify. This is the same as saying square root of 80 over the square root of 25. Square root of 80, if we're trying to think what values go into 80, well, we might start with 4, for example. So 4 times 20. Let me just keep concentrating on the numerator here. Square root of 4 is 2 times square root of 20 is the same as 4 times 5, which would give me 2 times square root of 4 is 2, so 2 times 2 is 4, square root of 5, and in the denominator, square root of 25 is 5. So we end up with what we're looking for. Notice that this value of b and b need to be the same, so I've got 5 under the square root sign of 5 in the denominator, and both a and b are positive integers, positive whole numbers, as we wanted. Being able to manipulate surds and fractions is quite important in exam 1. It is assumed knowledge that we know how to do this. So if there's something that confused you with the work with surds and fractions there, please do let me know so that we can have a look at it together. That's all for today. Please let me know if you spotted any errors anywhere or if you need any further clarification. Thanks for watching.